This video is going to look at the third problem in the exponential section of our midterm review. This particular problem, when you looked at it, hopefully you realize pretty quickly that part A there is the exact same thing as the statement in the original problem and was a typo on my part. So do not worry about that or stress about it. So we're just going to cross that out. This problem actually really only had sort of two sections to worry about, part B and part C. So in this problem, we're told July 1953, the US population was 160.2 million people. And then by July 2011, the population had doubled. So we are going to answer some questions knowing the doubling time. All right, the first question we're asked to do is to find an exponential equation for this particular situation. And this would be a really good time to go back and take a look at your exponential function notes, because this may be something that you would then want to make sure you would include in those notes. And so, because there are sort of two different ways to approach this. One option would be to simply go through and use the exponential function formula, where we have the initial value times 1 plus or minus the relative constant rate and then our input letter. And then option two would be actually use some of our doubling time formulas, and this goes back to what were you comfortable dealing with when you sort of worked through this lesson. Now, let's say I'm going to give two variables first, and then we'll sort of talk about the two different strategies and what would you prefer to use. So I'm going to make T represent the years since 1953, and then I'm going to have P represent the population in millions of the US. I should say population of the US. So always good, let's define our variables. Now, if I want to use my doubling equation, that's probably the simplest strategy. And in that case, what happens is I have my output letter, so that would be P, equals my initial population, so the 160.2 times, and I know that it doubles, but the issue is it doesn't double every year. I have to sort of make it less. So the time it takes to double. So in this case, that was from 2011 to 1953. So if I subtract those two values, I find that it took 58 years to double. And so I would actually have T over 58 here. And this equation is an exponential equation for the situation. It totally works. But sometimes you're asked for that annual growth rate, and in which case we'd actually want to tackle this problem slightly differently. There's nothing wrong with the strategy we used here. In fact, I actually will use this equation to answer part C. But let's say I wanted to create an exponential function based on the annual growth rate. Well, to find the annual growth rate, I would do that 2, and then I would want to figure out what's 1/58th, sort of raise that to the 1, because I want my annual, my 1 out of the 58 years that it actually took it to double. And this is going to get me that annual growth factor. And in this case, it came out to 1.012023. And I like to take it a lot of extra decimal places just in case. And so I could rewrite this exponential equation, and instead it would be 160.2 times, and then I'd have that annual growth rate. And because it's an annual growth rate, I just have to raise it to the T power. And you might be going, how are these connected? Well, it's that 2 to the 1/58 part is built within that doubling time equation. Either would be acceptable if you were asked to create a situation like this. Now, I'm going to tend to use this first one when actually answering a question like Part C, because it's more exact versus I had to round in the other one with that annual growth factor. And so I tend to go with exact values if I can. Now we're asked, okay, can we use this to figure out what is the population in 2035? Well, we're going from, first thing I need to know is how many years from 1953 is 2035. So I'm going to do 2035 minus 1953. And I find out that that's 82 years. And so this is what I'm going to be plugging in for t into my exponential equation. So p equals 160.2, 2 to the 82 out of 58. And I would end up with 400. And yeah, I just put that in a graphing calculator. I don't try and do any of that by hand. And so I already did that. And I would get 426.832. It helps if I write the number like I said the number. So 832 million people. And since it's people measured in millions, yes, I can't have decimals. And so that's all that it's looking for in that second part. So hopefully this clarifies a little bit about some doubling time situations and how I could use the doubling time equation, or I could just use a basic exponential equation. And these are formulas that we might want to include on that reference sheet we were able to build. These are great things, like go back, look at those exponential function notes and the things in the boxes and think about, would any of those help me when I'm taking my midterm?